Hello guys, so in this video me and my friend will going to talk about how to apply maximum and minimum problems in the application of differentiation. So let's go. In our video we will explain about the introduction, problem statement, problem solution and the conclusion. So let's get into it. So first of all, let me introduce myself. My name is Nabil Iskandar bin Muhammad Fadli. Nice to meet you guys. Okay, first, what is the maximum and the minimum volume? As you guys know, minimum is the high point and minimum is the low point. The process of finding the maximum and the minimum is called optimization. These are very important to the world of industry. For example, we can find the maximum profit in a company and minimize the cost that we can use. For our topic, which is differentiation, we will find the maximum of the possible volume of the box. Okay, next, why apply maximum and minimum problem? Typically, in order to maximize or decrease a quantity, someone will pose the question, what is the biggest volume of the parcel that the post office will accept? How can I go from here to there the quickest? Or what is the most cost-effective approach to complete this task? So, just like what I said before, we can know the maximum and the minimum volume using the differentiation. Okay, next, before we start into the problem statement, let me introduce to you guys about what is the calculus. So, calculus is a discipline of mathematics that focus on calculating instantaneous rate of change. Different with the normal mathematics, calculus adding an unlimited number of minor elements to a single whole. Calculus was independently created in 17th century by two mathematicians, which is Gottfried Wilhelm Leibniz of Germany and Isaac Newton of England. Anyone who want to study physics, chemistry, biology, economics, finance or actuarial science should start with calculus as their foundational course. Calculus is very important in our world. Calculus enables the solution of variety of issues, including tracking the position of a space shuttle and forecasting the pressure that will build behind the dam as the water level rise. Well, without further ado, let's go into our problem statement.
Assalamualaikum and hi, my name is Muhammad Fitri bin Muhammad Zainuddin and my student ID is 20224X6342. So, first of all, we have 3 steps to solving maximum and minimum problem. First step is find the derivative. Second step, let the derivative equal to 0 and find the value s of the variable. Third step, second derivative test. If second derivative greater than 0, it will be minimum value. If second derivative smaller than 0, it will be maximum value. The problem statement is a manufacturer wants to design an open box that has a square base and a surface area of 144 cm squared. First question is find the dimensions of the box such that the volume is maximum. Second question is determine the maximum volume.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil bin Aslan and today I'm going to continue my part, which is problem solution. Okay, first thing first, what we need to do is we need to understand the problem statement. We need to understand what the problem statement gave us and we need to read it thoroughly. For instance, this question states that a manufacturer wants to design an open box that has a square base and a surface area of 144 cm squared. The question A states that find the dimension of the box such that the volume is maximum. So from this statement alone, we can come up with a formula, which is given that V equal to x squared y. Given an area is 144, we can compute it inside the formula and we can use it. But we need to also remember that the question states that the manufacturer want to design an open box, which doesn't conclude the top part. That's why we use 4xy equal to 144. After we compute it, we can bring the 4x and x squared to the side, and we get y equal to 144 minus x squared over 4x. And then, since we already get the value of y, we can compute it back in the formula. V equal x squared y, so it became x squared bracket 144 minus x squared over 4x. And then we simplified it so that we get 36x minus 1 over 4x cubed. With the equation that we get before, we can now proceed with the first step, which is find the derivative. Using the equation v equal to 36x minus 1 over 4x cubed, we can derive it so that it became dv over dx equals to 36 minus 3 over 4 x squared. And then we can proceed to the next step, which is let the derivative be equal to 0. So first, let dv over dx equal to 0. Put the derived equation equal to 0. So 36 minus 3 over 4 x squared equal to 0, so that we could gain the x. Now if we calculate it, x will be equal to square root 48 centimeters. And then we can proceed with the last step, which is second derivative test, where we need to find where we could find the maximum value based on the second derivative test. So what we need to do is d squared v over dx squared equal 0 minus 3 over 2x, which will be equal to negative 3 over 2x. Since from the second step we already gained x, we can compute the x into the formula. So when x equal to square root 48, it is now d squared v over dx squared equal to negative 3 over 2 bracket square root 48, which will be equal to negative 10.39, which shows that it is less than 0. So within this calculation, we understand that x equal to square root 48 is a maximum value. That's for question A. For question B, it is stated that the question wants to determine the maximum volume. There are two ways or two methods that we can use. The first one is that we can use the first equation that we get from before, which is the Vmax equal to x squared equal y. And then compute the, since we already have the value of x and y, we can compute it inside the formula. So it will be square root 48 square times 3.46 equals to 166.08 centimeter cube. Or what we can do is we can use the first derivative. So it will become Vmax equal to 36x minus 1 over 4x cubed. Compute the value of x and y. So it became 36 times bracket times square root 48 minus 1 over 4 times square root 48 cube. For the second method, we can use the first derivative and we can compute the value of x and y inside it. So Vmax equal to 36x minus 1 over 4 x cubed. Right now became 36 times square root 48 minus 1 over 4 times square root 48 cube equals to 168 centimeters cube.
My name is Muhammad Zufairi bin Mahlan Nafi. My ID student is 2022864132. In conclusion, we must follow the step to solving maximum and minimum problem. We can use formula first derivative and second derivative to find maximum and minimum value. We can say that formula apply maximum and minimum problem is important and at least useful. In real life, we can calculate many objects to searching their volume using this formula. This also means the formula can help many professional engineering to calculate the volume of the object. The main point is subject calculus is important for all engineering to solve their problem.
Thank you for watching, guys. If you like this video, don't forget to hit the like button and subscribe to my channel. Bye.